Hi everyone. The today topic is graph theory and types of graphs. A foundational introduction to the mathematics of connection and relationship. So I am Mr. V. Ratanakumar, Head of the Department of Mathematics, PPG College of Arts and Science. Now, what is graph theory? The graph theory is a branch of mathematics that studies relationship between objects. It provides a precise language for modeling networks from social connection to computer system. So generally, the definition is graph is formally written as G is equal to V comma E, where V is set of vertices and E is set of edges. For example, so we consider V is equal to A comma B comma C, these are the vertices, and E equal to the first order per A to B, that is a single edge, and B to C, again that's a edge. Before we are going to study about graph theory, we should know some basic terminologies. First one is vertex. A point or node in the graph, that is a fundamental unit. And second one is edge, a line connecting two vertices representing a relationship. And the third one is degree, the number of edges incident to a vertex. And fourth is a path, a sequence of connected vertices traversed in order. And fifth one is cycle, a path that starts and the end at the same vertex. So these are the basic terminologies. And then the definition for a simple graph. A simple graph is the most commonly used graph type. It places two distinct restrictions on structure. The first one is it should not have a loop. That means an edge cannot connect a vertex to itself. And the second one is no multiple edges. That is, only one edge may exist between any two vertices. For example, in a vertex set 1, 2, 3, 4, and the edge set 1, 2, and 2, 3, and 3, 4. Simple graphs are widely used in network representation due to their clarity and ease of analysis. And then a complete graph. This is a definition for complete graph. In a complete graph, every vertex is directly connected to each other vertex. The complete graph on n vertices is denoted by Kn. And this is a formula for complete graph with how many number of edges are there with the graph of n vertices. A complete graph with n vertices has exactly n into n minus 1 divided by 2 edges. For example, consider a complete graph of 4 vertex, that is K4. It has 6 edges. The definition for null graph. A null graph contains vertices but no edges whatsoever. Every vertex is completely isolated from each other. For example, V is equal to 1, 2, 3, 4. These are the vertex, and E equal to empty. That is, it should not have a single edge. The null graph is the mathematical opposite of a complete graph. It represents a network with zero connection. And then a directed graph. In a directed graph, every edge has a direction. It goes from one vertex to another. An edge A to B does not imply B to A. These directed graphs are used in many real-time situations. The traffic system, one-way streets and traffic flow modeling. Second one is social media, follower relationship, and platforms like Twitter. And third, web links, hyperlink between web pages. And then undirected graph. In an undirected graph, it have no directions. A connection between A and B is mutual. It works both way automatically. So it's describe a relationship network, mutual friendship on social platform. And then a roadmap, two-way roads between cities. The next definition is connected graph. A graph is connected if there exists a path between every pair of vertices. No vertex is left isolated or unreachable. The key property is, in a connected graph with n vertices, you can travel from any node to any other node. Here the node is vertex by following edges. There are no disconnected islands in the network. If even one vertex cannot be reached from another, the graph is called a disconnected graph. And these are the application and conclusion. The graph theory mostly used in several areas, and I mentioned here some few areas. The first one is computer networks, that is routing and data flow, and it is used in Google Maps to find a shortest path between any two cities. And the third is social networks, community detection, and fourth one is artificial intelligence, knowledge graphs, and fifth one is electrical circuit. It is used to find circuit topology analysis, and the sixth one is transportations to find the route optimization. Graph theory provides the mathematical foundation for understanding connections from the simplest network to the most complex real-world problem. Thank you.